Hello, I'm the Stork. You may not believe in me, but I've been getting a lot of complaints lately. And maybe you think you know everything about what I do, or maybe not. Sometimes a doctor, a diagnostic radiologist, is asked to do a study of a woman's anatomy when she can't get pregnant. Often the woman and her husband are completely normal by every measure, and usually in that case, the study is completely normal. Think how strange that is. Most systems in the body have a lot of reserve, and here's the most important system of all, failing. Badgers don't have opposable thumbs. Oak trees don't have brains. Sponges don't have stereo vision, but they all make babies. So here is this woman with perfect thumbs, a miraculous brain, and 20/20 vision all working perfectly, but she can't make babies. Okay, so here are some numbers from the United Nations. The birth rate in the developed world has dropped below replacement level and has stayed there for decades. Lots of luck surviving if you can't get me to bring you more babies. Well, you wouldn't want to have too many people. The world can only feed and clean up after so many. In the least developed parts of the world, they still have babies, but fewer and fewer all the time. The blue represents the least developed part of the world, the yellow is moderately developed, and the red is the most developed. Look at the blue part of our graph. These are the poor countries. They have the most babies and can least afford them, and their birth rate is dropping fastest of all. So what's going on here? Let's rearrange the data like this. Look, it's all the same curve. Whatever is going on is affecting everybody in the world. Some of us are just at different points along the line. If there are less than 2 children per woman, mankind cannot survive for long. Let's look at some more data. Sometimes studies are done in which people go out and count animals every year for a while and then publish what they find as scientific paper. Then, some people did a study where they took over 1,000 of those papers and compared growth rate with population density. From density, they calculated population size. Here is what they found. As the population gets denser, the growth rate falls, but it tends to level off. As the population gets less dense, the growth rate rises faster and faster. We know inbreeding is bad, so at some point the growth rate has to fall again when the population is so small that every generation, any one animal, only meets others of its kind that are very close relatives. So we have to add in the inbreeding part of the curve. Now you can see that it is the same curve we saw when we were looking at the UN numbers. There is a pattern here. Then some people in Iceland did a study of kinship and fertility. They went back 10 generations and calculated who was effectively a second cousin and third cousin and a fourth based on the number of ancestors they shared 10 generations before. Here's what they got. They didn't see any effect of inbreeding unless they looked for the number of grandchildren. It turns out third and fourth cousins have the most grandchildren. By the time you go out to seventh cousins, your chance of having enough grandchildren to replace yourself is poor. You won't be getting a visit from me, and neither will your children, so this process works out over multiple generations. Interesting! We've now seen the same basic curve from 3 completely different sources. Once you get to a mate distant enough to avoid inbreeding, but not too distant, you have the best fertility and get the most visits from me, the Stork. I bet you didn't know that about me. And the curve is the same. Rapid rise in fertility as you escape inbreeding, rapid fall as you go farther out, and then it tends to level off after falling below replacement. Then they did a study in Denmark. They looked at how far apart couples were born and compared that with how many children they had. Closer than 100 kilometers apart, the closer they were together when they were born, the fewer the children. But when they went out farther, the number born was also lower. The curve does not look exactly the same, but when we adjust for the fact that population size is proportional to area, not to distance, it looks more like what we have seen before. So my radiologist friend was suspicious. He taught himself C language and wrote a computer program to make a virtual population with virtual genes, chromosomes, mutations, and had genes tuned to each other. Of course, they have to be tuned to each other. Any mechanism has to have parts that work together. And of course, he assumed that the human genome had been optimized. He could enter in things like mutation rates and the number of offspring a couple could have if there were no mutation to worry about. Once he had the right settings, he kept everything else the same and only changed the maximum population size. There were about as many genes as could be kept, because keeping a gene basically means losing babies because of mutations. You can only take that so far. He would try to run each population for 1,000 generations, seeing how many offspring there were each generation. Here is what he found. At very low population sizes, about 5, the group would usually die out from inbreeding. We knew that. Then, as inbreeding was escaped, the growth rate became maximal. Then it quickly fell, with the most stable populations about 200, and then leveled off below replacement with some populations going extinct. It's the same curve again. So then my radiologist friend, out of morbid curiosity, decided to see just how awful he could be to his virtual community and loaded his computer up with the biggest population it could manage. Of course they all went extinct, but what he found was this. The population tended to surge and crash, and the time from surge to crash was always about the same. This is an example. Well, that couldn't be, could it? Every time you had a dynasty or an empire or a civilization, it died out at the same age or maybe before. So he looked at Chinese dynasties. Let's take a look at the graph. The vertical axis is the chance the dynasty has of lasting another 50 years. The horizontal axis is the age of the dynasties. Sure enough, they all seem to die off after about 300 years. China, the red line, has been an imperial society. Everybody was either part of the royal club or a primary producer, like a peasant, with no opportunities to travel around. So the Chinese people survived, but the leader died off at a predictable time. Japan, the yellow line, has been a feudal society, with powerful families other than the emperor. So for the first 50 years or so, the new dynasty had to compete with the other powerful families. Then they settled down. But they had not been primary producers. They were power merchants already with a broad social horizon and already marrying outside of the immediate group. They began to die off sooner and were all gone after 300 years. On the graph, Egypt is shown here in orange. Setting up a regime in Egypt is really hard. The shakedown period is much longer than in Japan. It is completed just as the expected fall in survival chance starts. Look though, 3 regimes made it past 300 years, and those did really well. They solved the problem somehow. Mesopotamia is represented here in pink. You don't take over Mesopotamia unless you already have an empire. So the fall begins at once. To get decent numbers, you have to add the Romans to the classical Mayans and the Anasazi of Chaco Canyon to get enough collapses to graph. The blue line is what you get. Here's England, shown in dark green. When William the Conqueror took over in 1066, he divided the land among his cronies and called them noble houses. Things have happened since then. The noble houses are still around, not the same ones, but they were never all wiped out and replaced, so it is a single regime. Clearly, Britannia waives the rules, so it can be done. Manage things right, and I'm always there for you. You know, just about every adolescent girl has had a boy she liked go off with someone else, and she was devastated. Her parents said, "Don't worry, there are lots of other fine boys in the world." And she's like, "No, you don't understand. This is worse than death. This is the end of the world." You know something? She may have picked out the wrong boy, but she was absolutely right about how important it was. Please help spread the word. This is too big a secret for this old bird. I'd like to get back to work delivering babies.